So today we're going to look at what algebraic terms are and how you combine algebraic terms or simplify an expression. So first of all, a term can be a number all by itself, which would be called a constant, and I'll talk about that in just a minute. That's a number. A variable could also be a term, or the product of a number and a variable. So here's some examples down this right column of some terms. And the first term is a product of a number and a variable. And I want to look over here so you can see what this really means. 3 times m, that term, means m plus m plus m. 3 m's added together, or 3 times m. Okay, then we have 2 terms here. We have 4 times t, which means t plus t plus t plus t, plus 6. So these are 2 separate terms. This is a product of a number and a variable, and this is a number, or we also call this a constant. Okay, and a constant is a number that never changes unless you're going to combine it with another constant. This changes depending on what t is. Okay, this term, 2 times x, means x plus x. This term, x squared, means I have x times x, which is different than x plus x. It's a product, but that would be a term by itself. Okay, so like terms are terms that have the exact, and that's so important, same variable or variables with the exact same exponents. So some like terms, we have 3m and 4m, those are like terms. And if we have to add those like terms together, if we combine them, we have 3 m's, which means m plus m plus m, like we saw from above. And then this plus sign is right here. And then 4 more m's added together. And all of those m's, there's 7 of them, so that's 7m. Another way to look at combining like terms, which if you have to rationalize and give reasons for each step, you would use the distributive property backwards, or factoring, and you would say, well, we have a common factor in each of these terms of m, so we can divide that m out of both terms, and if I divide m out of 3m, I get 3 left, plus, if I divide m out of 4m, I get 4. So then 3 plus 4 is equal to 7, and so 7m, and that's what you get if you look at it in expanded form as well. Okay, then the next example, you have 2x squares and 3x squares, and so that's my dog being yelled at. If you add those together, those 2 like terms, you get 2x squares, so here's those 2, plus 3 more, and altogether that's 5. Or if you use the distributive property, you would say there's a common factor of x squared, and then if you divide it out of both terms, you divide x squared out of there, you get 2. Divide x squared out of there, and you get 3. 2 plus 3 is 5, and so you get 5, x squared. All right, so simplifying an algebraic statement. If I've got 3x squared plus x plus 7 plus x squared plus 2x plus 5. First of all, the best thing to do is get your like terms next to each other, and we can do that by the commutative property, means we can move their places because it's all addition. So what I'm going to do is I'm going to move the x squared next to the 3x squared. I'm going to move this x and 2x together, and then at the end I'm going to put my constants. And normally when we start simplifying, we start with the highest exponent first, then the next exponent, which would be like a 1 exponent there, and then the constants go to the end. Now, you can go ahead and combine these like we did up here. We don't have to show this, and you don't have to show this unless they want you to justify your steps. Okay, so if we're going to combine 3x squares and 1 more x square, then there's 3 x squares added together plus 1 more x square makes 4. So what you can do is just look at the coefficients, and up here my coefficients were 3 and 4, and I added those together and got 7 m's. Here my coefficients were 2 and 3. I added those together and got 5x squared. So I can add 3x squared plus 1x squared and get 4x squares, plus, then I've got an x, and that would be like a 1x, and its like term 2x. So I can combine those coefficients and get 3x's, plus, then I can combine my constants, 7 and 5, and get 12. In the next step, just showing where that's coming from, you have 3x squares. You don't have to show this work. I'm just showing you why. 3x squares, that's like this, plus the other x squared, and that's where we got our 4x squares. Add them all together, like terms. And then I have 1x and 2 more x's, so there's the 1x, and then there's the 2 more x's, the 2x, and you add those together, there's 3 of them, and then, of course, the 7 and the 5. And my simplified form, there it is again. You can leave out this step. Okay, I want to show you one more example. And so your directions are always going to be, for these types of problems, to simplify. So I'm going to have you simplify 7x minus, you have to write this down yourself, minus 3, plus x, plus 1. Okay, so the first thing we did up here is we rearranged them and put like terms together. But I cannot rearrange these until I change it to addition. So that way you know that that minus 3 is really plus a negative 3. So that negative travels with that 3. And I'm going to go ahead and put a 1 in front of this x since there's only one of them. Now I'm going to rearrange them, and I'm going to put 7x plus 1x together. And then I'm going to do my plus negative 3 plus the 1. Now I can combine the coefficients. So 7x's and 1 more x makes 8x, plus, and then negative 3 plus 1 is negative 2. And if you want, you could change that back to a subtraction problem and say that's 8x minus 2. All right, so that is the example I gave you, and then you can work on some other examples tomorrow in class. Have a good evening.